Flip to Thursday's page in the packet and take a look at this two-part assignment. The top half of the page has different instructions than the bottom half of the page. Now, normally on Thursdays, what you guys would do is you would work through all these problems on your own, and then you would watch the Ed puzzle to check your work. But today, I'm going to be your Ed puzzle. So what we'll do is, I'm looking at skills practice. So what we'll do is I'm going to work through number 1 with you, and then you guys are going to work through 2 through 8. And I'm going to kind of walk around and check on you and answer questions and point out mistakes and see if I can help you a little bit. And when it seems like most students are finished with 1 through 8, then I'll really quickly do all of these problems on the board, and that will be your way of checking your work. And then we'll repeat the same process with the second half of the page. So let's take a look at number 1. The instructions for this problem say, rewrite each rational exponent in radical form, or rewrite each radical in exponent form. So all we have to do on these problems is if it's written as a radical, we need to change it to an exponent. If it's written as an exponent, we need to change it to a radical. That's it, okay? We're not doing a lot of fancy stuff here. So for number 1, this is a radical. We need to change it into an exponent. In order to do that, first we have to identify the base. The base is
or 3x.
A 3x?
13x.
13x, that's very good. So the base is going to be whatever is written here inside your radicand. In this case, it's 13x. Since our base has multiple pieces, we have to put parentheses around it. That's very, very important. Our base is that whole expression, 13x. Then we're going to put an exponent on this 13x. The exponent comes from here, but there's nothing written there, so we just write in a 1. And then we put that 1 over the index. What's the index of this one? 2. Thank you. That tricks some students.
Square.
Because if there's no index written, we treat it like a square root. That's exactly right. So our answer to this problem is just 13x to the 1/2 power. But you have to have parentheses there or your answer is wrong. And that's all we have to do on number 1. It's just a conversion problem. So why don't you attempt 2 through 8 on your own? Pay attention to these. Some of them are radicals that you have to change into an exponent. Some of them are exponents that you have to change into a radical. We are going to now work through the problems 2 through 8. So pretend I'm an Ed puzzle video and you can't fast forward me. Check your work as I'm working through these problems. If you've made any mistakes, you need to fix those mistakes because you're going to be turning this in and all of your work needs to be correct. So let's look at number 2 together. This is a radical and we need to write it as an exponent. So we start with the base. Our base is x. And then we write our exponent, which is 2, over our index, which is 3. And we get x to the 2/3. It's that easy. It's just a matter of knowing what goes where. For number 3, we're doing the opposite. We are going from an exponent to a radical. So the first thing I'm going to do is draw a radical symbol. That gives me sort of a structure I can work with. We need to figure out what the base of this exponent is. The base is the thing that the exponent is directly touching, which is just x. So the x is what goes inside the radical. Now its exponent will come from the fraction, the 3/4. Its exponent is 3 and its index is 4. And that comes from this 3 over 4 in the fraction. What about this? We have this other 4 out front that isn't part of the radical because it wasn't part of the base. Where does that go? Anybody? Right out in front. It started out in front. It stays out in front. It doesn't go anywhere. It's just there. Okay, so just be careful with that. I saw a ton of students who tried to put this 4 underneath the radical symbol with the x, but it's not part of the base, so it doesn't belong in there. It stays on the outside. So that will hopefully help with number with number 4 as well. So here's number 4. I know a lot of students have a question about 4, so you might want to pay attention to this one.
Yep.
We have 7ab to the 2/3. We're going to convert this into a radical, so I'm going to start by writing a radical symbol. What is the base of the exponent? Just b. It's the thing that the exponent is directly touching, which is just the b. So inside of our radical, we're going to put b. The exponent on the b is 2, and the index is 3. What do we do with that 7a? Out
It goes
front.
out in front.
Out in front. Yeah. So the things that can be out front, they don't have to just be numbers. They can be letters too. A belongs out front here. All right, number 5. Number 5 is a little bit tricky because it has parentheses. So when I ask this question, what is the base of that exponent? Your answer better be
21R.
21R. But even more importantly, it's not just 21R, it's also those parentheses. This is kind of a weird algebra concept, but the parentheses are part of the base. So when we write our radical and put our base inside, we need to have those parentheses there too, at least at first. The exponent is 1 and the index is 2. So I do want to point out something about this number 5. When you're taking your quiz tomorrow, your quiz is going to be multiple choice. And if you have a problem like this and you get this as your answer, there's a very good chance that none of the multiple choice options are going to look exactly like this. Well, why not? Well, that's because, remember, when you have a square root, when your index is 2, you don't normally write it. So the answer probably wouldn't have this 2 here.
Just be 21R.
Exactly. And also, you probably wouldn't write this exponent because we don't normally write exponents of 1. So you can get rid of that too. And also, now that the exponent is gone, you can get rid of the parentheses as well. So really, your answer should just be the square root of 21R. So these types of problems can look like very different forms, even though they mean the same thing. So just look out for that, especially on multiple choice, if your answer doesn't look exactly like their answer. Okay, for number 16, we have an exponent that we need to convert into a radical. So I'm going to write a radical symbol. What is the base of that exponent? AB. Very good. So this one has parentheses. Parentheses, AB, parentheses. So we've got parentheses, AB, parentheses. This is important. A lot of students didn't do this. These parentheses have to be here inside your radical. If you didn't put these in, you're wrong, okay? Because of this exponent, 2. If you just wrote AB squared like this without parentheses, that is incorrect. Be careful. All right, so we also have this 13 out front. Let's talk about why these parentheses are so important. So let's say you're taking your quiz tomorrow, and you do this problem and you write your answer like this, and none of the answer choices look like this. Let's talk about another form that the answer choices might take. The AB squared, this 2 here can be distributed in through the parentheses. We could write this as A squared B squared. Because that 2, that exponent, is affecting both the A and the B. And we learned our exponent rules last week. You can distribute that in. So this answer would be just as correct as this answer. They're both correct. The problem is, on a multiple choice test, you don't just get to write your answer in. You have to select the right answer. So you have to be able to recognize these 2 things and know that they both mean the same thing and they're both right answers, and you have to pick the one from the list that matches one of these 2 things. Does that make sense?
Yes, ma'am.
Thank you. Let's move on to 7. All right, so number 7. Number 7 is easier than it looks. This is a conversion from a radical to an exponent. So we start with our base, which is x, and then we put our exponent, 9, over the index, which is 3. All right, for number 7, we have x to the 9 over 3, which is correct. But this might not be the way the answer is written on a multiple choice test. Is there a way we could simplify this? What's 9/3? 9/3 is a fraction. Can it simplify? Yeah, what would 9/3 simplify to? 3. So 9 divided by 3 is just 3. This fraction can simplify to 3. So our answer could be written as x cubed. So if you're taking a quiz and you look at your answer choices and this one is not an option on the answer choices, check to see if your answer can be simplified into one of the other answer choices. So once you do number 7, number 8 should seem pretty similar. We are going to convert this into an exponent. So we start with our base. Our base is parentheses 4y parentheses. And if you don't have those parentheses in there, you're going to be wrong. So caution. To the 8/4, the exponent over the index. And again, 8/4 is just a fraction, and that simplifies to 8/4 simplifies to 2. So you could rewrite this as parentheses 4y parentheses squared. So far, this is correct. This is correct. But that still might not be the way the answer is written on a multiple choice test. So we might still have to be able to manipulate this a little bit more. The 4 and the y in parentheses are both being taken to the second power. So we can distribute that exponent in through the parentheses and write it as 4 squared y squared. And that's correct too. This is a totally acceptable way to write your answer. But we could write it one more step simpler. What's 4 squared? 4 times 4? 16. So we could write our answer as 16y squared. All right, students, we're going to now start working on the second half. Before we do, I want to show you number 9. So the instructions say to simplify the radical. But some of these questions don't have a radical in them. So first we have to convert it into a radical and then simplify. So for number 9, you already know how to convert this. We rewrite it as with 5/12 as our base, 1 is our exponent, and 3 is our index. So we convert this into a radical, and then once we've done that, we simplify it. So how do we simplify a cubed root? We learned how to simplify a square root, but simplifying a cubed root requires us to find a number that multiplies to itself 3 times to equal 512. And these are a job for a calculator. So pull a calculator out or snag one off the desk beside you. Type in a few options until you can figure out a number that multiplies to itself 3 times to equal 512. So like try 4 times 4 times 4, 5 times 5 times 5. See what you can get to work. 8. That's what you got? So everybody try that. If you punch in 8 times 8 times 8 into a calculator, you get 512. So the cubed root of 512 is 8. Now notice that simplified down really nicely, right? Pull those calculators back up. Get these big graphing calculators, turn it on, and I want y'all to type this in. Ready? 512. And then there's a little power button. It's kind of on the top rightish, right above the division symbol. It looks like a caret, a little arrow facing up. Hit that, and then type in 1/3. So 1 divided by 3.
What one is the caret?
It looks like a little arrow. It's on the right-hand side. And it's right above the division symbol. And if you hit enter, what do you get? 8. 512 to the 1/3 power. You can plug that into your calculator. And if you get this nice, neat, rounded number, then you're done. And if you're taking a quiz and you do a problem like this that can be rounded using a calculator, all you have to do on your paper is say use calculator, and that can be you showing your work. You are in a class where you are allowed to use a calculator. And if your calculations can be done with a calculator with no problem, that's acceptable. Here's the problem though. Try to do the same thing, but instead of 512, type in 510 to the 1/3. 510 to the 1/3. What do you get this time? 7.989 something, right? If you get a decimal number, that means that the calculator isn't working and you can't use the calculator on that one. I mean, it doesn't mean the calculator's not working. It just means the calculator isn't simplifying it the way you need it to. So on a problem, if a calculator gives you a rounded answer, you can use the calculator and just say use calculator on your page. All right, so why don't you guys try 10, 11, and 12?
Wait, can you take one of the, we'll be here to take the test.
Yeah, you'll be taking your
We can use this.
learning check in class tomorrow.
Alright.
So why don't you guys try 10, 11, and 12? Stop before you get to 13.
So that might help too.
Okay.
All
All right, students, we are going to now talk about 10, 11, and 12. I think everybody's done or close to being done with most of these problems. So let's talk about them together. Number 10 is just like number 9. First, we have to rewrite it as a radical. So put a radical here. Inside the radical, we put our base, 3,125 to the first power with an index of 5. But we don't have to write the first power. That's a little silly, so we'll get rid of that. We are looking for a number that multiplies to itself 5 times to equal 3,125. So it might take a little bit of calculator work to figure out what this number is. You know, you might try 3 times 3 times 3 times 3, 4 times 4 times 4 times 4.
I know the answer is.
What is it, Mason?
What was number 10?
Yep, it's 5. When you type in 5 times 5 times 5 times 5 times 5, you get 3,125. So that's our simplified answer, just 5. Now number 11 is a little bit more complicated because it has a fraction involved, but don't let that throw you off. Here we start by rewriting this as a radical. So our base goes inside, exponent and index. So we don't need to write that exponent because it's a 1, which also means we don't even really need those parentheses because there's no exponent. So this is what we're looking at, the 5th root of 32 over 1024. Well, in this problem, we can only really look at the 32 and the 1024 separately. So we could think of this as the 5th root of 32 over the 5th root of 1024. So we're just going to do this exercise twice. We need something that multiplies to itself 5 times to equal 32. Any thoughts? 2. 2 times 2 times 2 times 2 times 2 gives us 32. So the top becomes 2. What about the bottom? We need the 5th root of 1024. We're looking for something that multiplies to itself 5 times to give us 1,024. And I heard someone yell it out. It's 4. Very good. So we can simplify this one more time because that's a fraction. We end up with 1/2.
Let's go, I got that right.
Awesome. I like the sound of that. Now for number 12, very similar problem. We start by rewriting it as a radical. Radical 1 over 81, and our index is 4. Then we can split this up into a top and a bottom. So the 4th root of 1 and the 4th root of 81, still in fraction form. What's the 4th root of 1? 1. You're just looking for something that multiplies to itself 4 times and equals 1. So 1 times 1 times 1 times 1. So very easy. Sometimes those easy ones can throw you off though, if you overthink them too much. All right, now on the bottom, we need a number that multiplies to itself 4 times to equal 81. 3 times 3 times 3 times 3. Very good. So our answer here is 1/3. Okay, so we're going to do 13 together, and then you're going to do 14 on your own. I want everybody to pick up their packet and look at Monday. Look at Monday's page on the packet. About halfway down, it says simplifying roots, step 1, step 2, step 3. This is what we're about to do. Step 1 says factor. Step 2 says pull out pairs of factors. And step 3 says recombine. Don't forget, guys, I feel like I have to remind students of this. You have these packets all week, from Monday all the way through Friday. When you're taking your quiz tomorrow, if you get stuck on something, flip back in your packet to Monday. That's why we want you to have these notes. We want you to take notes and have the notes so you can go back and read them later if you forget something. That's what the notes are for. So while you're taking your quiz, if you need a little bit of a reminder or a refresher what to do on a problem, flip back to Monday. All the notes will be there. All right, so let's get back to Thursday's page. So you can flip back to Thursday and take a look at 13. We're going to follow the 3 steps: factor, pull out pairs, and then recombine. So start with factoring. Let's take 72 and split it up as much as possible. I need 2 things that multiply together to give me 72. Anybody? 9 and 8, great. 9 times 8, 72. 9 can split up again. 3 times 3. 8 can split up again. 2 times 4. And 4 can split up again. But then I think we're done. So when I factor this out as much as I can, I end up with 3, 3, 2, 2, 2. So what we're gonna do now is rewrite this, but instead of 72, I'm gonna break that 72 up into its factored form. So I'll write it as 2 times 2 times 2 times 3 times 3. And this comes from my factoring. We're not just going to break up the number, though. We can also break up the variables. A cubed, that's just A times A times A. 3 of them. All right, so I did the A's. Now for the B's, B to the 4th is B times B times B times B. So we can write that out as well. And that's step 1. So step 1 was factor everything out as much as possible. Moving on to step 2. Step 2 is find pairs of factors and pull those out front. So I'm going to circle any pairs I see. I see 2s, I see 3s, I see A's and B's and B's. Each one of these pairs can move out front. The thing is, when we move it out front, we pull the pair as a unit. So for instance, with the 2s here, I don't bring 2 2s out front. I just bring a pair of 2s, or I bring a single 2 out front. So we'll have a 2 here, a 3, an A, a B, and a B all out front. But left over inside the root, I still have a 2 and an A that were kind of left behind. That little 2 and that A didn't have anything to pair with. They're all alone and they stay inside the radical. Now we move on to step 3, which is recombine. So for instance, we've got a lot of stuff out front now, like this 2 times 3 and this B times B. We can put those things together now. We wouldn't typically write our answer like this. So now I'll recombine that into a 6AB squared times the square root of 2A. And that's your answer for number 13. So there's not very much time left. I want you guys to try number 14 on your own. You only have a few minutes, so you might not be able to finish it. And I'm gonna write the answer up on the board so that you have the answer later. But you need to show all the work to get to the answer. So if all you have is the answer, you're not going to get full credit. You have to show your work to get to the answer to get full credit on this one.